Understanding derivatives, the key to measuring change. In this video, we're going to explore the concept of derivatives, starting with the basic idea of a slope. A slope describes the rate of change of a vertical variable with respect to a horizontal variable. For example, imagine a graph with the y-axis representing the vertical direction and the x-axis representing the horizontal direction. To calculate the slope of a line on this graph, we can pick 2 points and determine how much the x and y values change between those points. The slope is the ratio of the change in y to the change in x, often described as rise over run. The slope of a line is constant. No matter where we pick 2 points on a straight line, the slope will always be the same. However, calculus introduces a fascinating concept, the rate of change for curves. This is because curves have different rates of change at different points. To get an idea of how fast E is changing with respect to x at a specific point on a curve, we can look at the tangent line at that point. A tangent line just touches the curve at that point, and its slope represents the instantaneous rate of change. This is where we enter the world of derivatives. The derivative is a mathematical tool that helps us determine the instantaneous rate of change of a function at any point. It tells us how fast y is changing at a given x value. The notation for a derivative comes from Leibniz's notation, one of the fathers of calculus. We represent the derivative as dy dx, which indicates the change in y with respect to the change in x. This notation is particularly useful because it connects directly to the idea of slope. As we'll see in future videos, the derivative is calculated by looking at the slope of secant lines between 2 points, and then taking the limit as the distance between those points approaches 0. Alternatively, the derivative can be written using the function notation. If a curve is described by the equation y equals sine a phi fx, the derivative at a point x1 is often written as f x1. This tells us the slope of the tangent line at that specific point. There's also another notation you might encounter, especially in physics, which uses a dot over the variable like y to indicate the derivative. As we continue our exploration of calculus, we'll build on these foundational concepts and learn how to compute derivatives for various functions. We'll also dive into more complex techniques, but this is the core idea. A derivative measures how a function is changing at any given point, and it's an essential tool for understanding rates of change in mathematics, physics, and beyond.